Welcome to Maths Bolo YouTube channel. So here we are going to discuss differentiation lecture 2. So this is lecture 2. In lecture 1 I have given you some homework and those homework problems will be solved over here first of all, and afterwards I will continue with the lecture. So first problem of lecture 1, homework of lecture 1. So first problem was to find the slope of the curve at the point indicated. So the equation was y equal 5x minus 3x square and the point is x equal 1. So we have dy upon dx which is equal to 5 minus 3 into 2 of x, and this is equal to 5 minus 6x. Now we have dy upon dx at the given point, that is x equal 1. So it is 5 minus 6 and this is equal to minus 1. So the slope is minus 1. We have the second question, that is y equal 1 upon x minus 1 and the given point is x equal 3. So we have dy upon dx which is equal to 0 minus 1 into 1 upon x minus 1 whole square, and this is equal to minus 1 upon x minus 1 whole square. So further we have dy upon dx at x equal 3. This is equal to minus 1 upon 4. So this is the slope for the second question. Now we will be moving towards the lecture second of differentiation, as we are providing at Maths Bolo the lecture series of differentiation, and further in the YouTube channel you will be finding various lecture to different mathematical topics, that is calculus, differential equation, and many more subtopics of differential equation, that is partial differential equation, ordinary differential equation, linear differential equation, and so on. So stay tuned, and I hope this will be a happy learning for you all. So we are continuing with lecture 2 of differentiation. Now in this lecture 2, the first topic is the derivative as a function. So here we have definition, and definition says the derivative of the function fx with respect to the variable x is the function f dash whose value at x is given by f dash x. This is equal to limit, and we have this as h. So h tends to 0, f of x plus h minus f of x upon h, provided the limit exists. Now further, alternative formula for the derivative is given as f dash x equals limit z tends to x, f of z minus f of x upon z minus x. So this is alternative formula for the web equation. Now further we have example. So differentiate f of x equal x upon x minus 1. So we have been given f of x as x upon x minus 1, and f of x plus h becomes x plus h upon x plus h minus 1. Now further we have f dash x, and this is equal to limit h tending to 0, f of x plus h minus f of x upon h. So it is limit h tending to 0, x plus h upon x plus h minus 1 minus x upon x minus 1 upon h. So we have therefore limit h tends to 0, 1 upon h into x plus h into x minus 1 minus x into x plus h minus 1 upon x plus h minus 1 into x minus 1. So further this is equal to limit h tends to 0, 1 upon h into minus h over x plus h minus 1 into x minus 1. And we have further this equals limit h tends to 0, minus 1 over x plus h minus 1 into x minus 1, that equals minus 1 upon x minus 1 whole square. So this is the derivative of this part, fx equal x upon x minus 1. This is the first principle of differentiation, that is, we assume the value, there is increment in the variable that is replaced by x plus h, and we solve the problem. But in the coming lectures, we will be seeing that we have some other shortcut ways also to find the derivative. Now, continuing with the lecture, we have the second topic, that is differentiability on an interval one-sided derivatives. So here we have the statement, that is a function y equal f of x is differentiable on an open interval that is finite or infinite. If it has a derivative at each point. Now, each point of the interval. Now, it is differentiable on a closed interval. So here it is. Differentiable on a closed interval a comma b if it is differentiable on the interior a comma b and if the limit exists at the endpoint. So this is the statement of differentiability on an interval. So this is represented here as limit h tends to 0 positive f of a plus h minus f of a upon h. So this is the right hand derivative at a, and we have limit h tends to 0 negative f of b plus h minus f of b over h. So this is left hand derivative at b. Now we have the theorem. So this is theorem first. This is differentiability implies continuity. Now here, if f has a derivative at x equals c, then f is continuous at x equals c. Now we have the proof also. So in the proof we have given that f dash c exists, we must show that limit x tends to c f of x equals f of c, or equivalently that limit h tends to 0 f of c plus h mine equals f of c. We have further the statement, that is if h is not equals 0, then f of c plus h equals f of c plus f of c plus h minus f of c. Here we have added and subtracted f of c. So this is written as f of c plus f of c plus h minus f of c upon h into h. Here we have divided and multiplied by h. Now further in the lecture we have now take limits as h tended to 0. Therefore we have limit h tending to 0 f of c plus h. This is equal to limit h tending to 0 f of c plus limit h tending to 0 f of c plus h minus f of c upon h into limit h tending to 0 h. So further this is given as f of c plus f dash c into 0, which is equal to f of c. Now further in the lecture we have some problems. So first one is finding derivatives or derivative functions and values. So here the statement of the question is calculate the derivative. So we have f of x equal 4 minus x square, and we have to find f dash 3, f dash 0 and f dash 1. So solution is f dash x equal minus twice of x, so f dash 3 equal minus 6, f dash 0 equal 0, f dash 1 equal minus 2. The other problem is g of t is equal to 1 upon t square, or it is given as g of t equal t to the power minus 2. So we have to find z dash minus 1, z dash 2 and g dash root over of 3. So we have g dash t equals minus 2 t to the power minus 3, and we have g dash 1 equal minus 2, g dash 2 equal minus 1 upon 4, and g dash root over of 3 is equal to minus 2 upon 3 root over of 3. So these are the problems which we have solved in the lecture. Now here are some of the problem for you to solve at your work or your home. So some of the homework problems are: p of theta is equal to root over of 3 theta. Now here this is the problem. So p of theta is equal to root over of 3 theta, and you have to find p dash 1, p dash 3, p dash 2 upon 3. So this is the first problem. Second problem is p dash x equals root over of twice of x. And here you have to find p dash 1 and p dash 2. So these are the two problems which you have to solve, and you have to post the solution in the comment section. Further moving towards the next topic, that is find the indicated derivatives. So we have the problem, that is dy upon dx, which is equal to, you have to find the indicated derivative, that is you have to find dy upon dx at, or the y is given as 2x cube. So the solution is given as d upon dx of 2x to the power 3, which is equal to 2 into 3x square, or it is 6x square. The other problem is ds upon dt if s equals t upon 2t plus 1. So we have d upon dt of t upon 2t plus 1. This is equal to dt upon dt into 2t plus 1 minus t into d upon dt of 2t plus 1 upon 2t plus 1 whole square. Now it is equal to 2t plus 1 minus 2t upon 2t plus 1 whole square. Now this is equal to 1 upon 2t plus 1 whole square. So this is the answer to this problem. And here also you have to solve one problem as homework. So you have to solve this problem and you have to comment in the comment section below. If you are not able to solve, then we will discuss it in the next lecture, that is lecture number 3. So don't worry, please attempt this problem. So the problem here is you have to find dp upon dq if p equal q to the power 3 upon 2. So this is the homework. Now moving towards the next topic in the lecture, we have slope and tangent line. So here statement says differentiate the functions and find the slope of the tangent line at the given value of the independent variables. So here the question is f of x equal x plus 9 upon x, that is written as x plus 9, x to the power minus 1, and x is equal to minus 3. So here we have the solution to this problem as f dash x equals 1 plus 9 into minus 1 into x to the power minus 2, which is equal to 1 minus 9 upon x square. Now You have to find it at x equals minus 3. So it is f dash minus 3 equals 1 minus 9 upon 9, which is equal to 0. In the second part, or the second question here is a is equal tq minus t square, and you have to find the ds upon dt at t equals minus 1. So this is ds upon dt equal 3t square minus 2t, and ds upon dt at t equal minus 1. This is equal to 3 into 1 minus 2 into minus 1. This is equal to 3 plus 2, that equals 5. We have the last problem to this lecture. So this is written as ds upon dt at t equal minus 1 if a is equal 1 minus 3t square. So we have ds upon dt equal 0 minus 3 into 2t. So we have ds upon dt at t equal minus 1, and it is equal to minus 6 into minus 1, and that is equal to 6. So here, this is the end of this lecture number 2. I hope you like the video and you like the differentiation lecture series. And I would remind you that this lecture series is very, very useful to the candidates who are at their pre-university level and university level or undergraduate courses. So stay tuned with Maths Bolo for the upcoming lecture series on differentiation and other various mathematical topics. Please hit the like button, share and subscribe the video. Thank you.